Top Secret. Psi Operative Training Mission. Reading Passage. Scientific Method. Mission. Understand the process of the scientific method for use in future missions. Tips. Remember to beam as you read through the passage below. Welcome back, Psi Operative. Even though the Hive managed to kidnap Aki and steal Aki's armor and Nikole's laser, all is not lost. Follow Nikole and Zia's conversation below as they return to the scene of the science fair to learn more about the scientific method. As you read, use the beam reading strategy. Details of this strategy are on the beam strategy sheet provided to you by your teacher. Refer to this sheet to help you complete the steps of beam as you read about Aki's project. Come on, Nikole. You've already remade your laser. We need to get moving if we are going to rescue your friend in time. Who knows what the Hive is making him do?
We're going to need more than just a laser if we are going to get Aki back. We're toast if we don't secure some kind of protection from incoming laser blasts.
But the Hive took Aki and his armor, so what are we going to do?
Aki had some notes on how he made the armor back at his project stand. We are going to find them and try to recreate it.
That might be difficult without Aki here.
If he followed the steps of the scientific method, like he was supposed to in the assignment, we should be able to recreate his armor just fine.
What makes this method so special?
Shouldn't you know that, being a Psi Operative and all?
I may have skimmed that part of the training. Give me a refresher?
The scientific method is a logical sequence of steps that scientists follow when conducting scientific experiments and investigations. Other scientists are able to follow the exact steps of the process to verify the work done by others. If Aki kept good notes, we will have a record of the steps he took to create his armor.
Let's hope he kept good notes then. His life literally depends on it now.
Don't remind me. Look over there. I think that's where his project stand was.
Can you make any sense of his board? It's all torn up from the Hive.
He's laid out the steps of the scientific method here in this diagram. It is important to note that while we think of the scientific method in steps or phases, scientists often go back and rework their hypothesis and retest their ideas many times after data analysis. Therefore, the process can be repetitive.
The diagram is a flowchart showing the steps of the scientific method in sequence: observation, question, research, hypothesis, experiment, data, and conclusion. An arrow flows from the conclusion back to observation, showing the cyclic nature of the process. Okay, so walk me through this.
First, he made some observations. An observation is anything that is noticed using one of our 5 senses. It is something that we see, hear, touch, smell, or taste. Once scientists have made an observation, they ask a question. These questions may include why something is happening, what would happen if something is changed in a scenario, or how a process or product can be improved.
It looks like Aki wrote his observations here on this board. Metals melt at different rates. Then he asks the question, how can I create body armor that can withstand long laser beam blasts without melting?
Nice catch! That checks out with the information here.
Is an observation and question enough to plan a whole experiment? Seems too easy.
Once scientists have a question in mind, they do research to learn more about the topic. You need to know what knowledge and facts already exist about the topic you're investigating. Aki's board has information about the properties of metals listed and the definition of melting point. He learned all that through the background research he did before performing his experiment on his prototype armor.
Aki's research. Properties of metals. Shiny, very hard, good conductors of heat, good conductors of electricity, higher densities. Most are solids at room temperature. Melting point, the temperature at which a given solid will undergo a phase change to become a liquid. Aki also included several photos of metals with his research. Look here, underneath the research section, there's a box labeled hypothesis. Why do we need a question and a hypothesis?
The initial question is made based on observations and what the scientist is curious about. Once a scientist has researched their question, they will develop a hypothesis.
Makes sense. So, let's look at the theories Aki has come up with.
Not quite. A hypothesis is different from a theory. Science uses the word theory in a way that is different from its everyday use.
I thought a theory was an untested hunch. How is that different?
A scientific theory is an explanation for observations of the natural world that is carefully thought out and has been created and supported by the scientific method, pulling together many facts and hypotheses. It attempts to explain how or why something happens and is very complex. A hypothesis is a testable explanation for what the scientist has observed. It is a starting point for creating an experiment to test their idea. In order for a hypothesis to support the process of science, it must be tested in a controlled experiment. Hypotheses are usually written as if-then statements.
So, Aki's hypothesis might have been something like, if I use metal with a higher melting point, then the armor will withstand more laser blasts.
Exactly. Aki has laid out his procedure beneath his hypothesis. These are the exact steps he followed during his experiment. But here under the Analyze Data section, the page seems to have been ripped away. I wonder what he had there.
It's a bit ironic that the Analyze section where we are supposed to examine the details of something is gone.
That would be funny if Aki wasn't in danger right now and needed us to know this information like yesterday. Luckily, all experiments create data. Data is factual information gathered from an experiment. It can include measurements, the sequence of events, and observations. When Aki tested his armor, he collected 2 types of data here in his project.
2 types of data?
Yes. Quantitative data are measurements or data that can be counted or compared with numbers. For Aki's experiment, that would be the temperature of the armor, the time it took to melt, and the weight of the armor. Data is often analyzed and classified to serve as evidence to support or reject an idea.
Quantitative is like quantity, like numbers. Got it.
He would have also collected qualitative data. Qualitative data is descriptive. In this experiment, it would be the order of events as the armor heated up and melted, and what he saw, heard, felt, and touched as he tested his prototype.
Okay, so Aki made observations, did research before testing his armor, created a hypothesis, did an experiment on his prototype armor, and analyzed his data. I see one more blank space on his board where something was ripped off. What would have been the last step of his project?
The last step of the scientific method is very important. It's reporting your conclusions. A conclusion is a summary statement of the experimental data. The conclusion can support a hypothesis, but it can also disprove a hypothesis. If a hypothesis is not supported, scientists go back to previous steps of the scientific method and create a new hypothesis based on their data.
And the cycle continues?
Yep. Conclusions are detailed explanations of the experiment and the data collected. They include explanations of the results and possible pathways for further research. The goal of science is not only to test ideas, but to have those tests be reproduced by other scientists. We do this by sharing the details of our results. If Aki wrote a good conclusion, it would tell us what he discovered through his tests.
Then what are we waiting for? We really need to find this missing piece.
Aki's notebook should still be in the lab. I bet we can use it to reproduce his work and rebuild his armor, especially now that I understand more about how he used the scientific method while testing his prototype. Let's go!
Make connections. In each box below, write a connection between the text that you just read and either your prior knowledge or something in your life. Reading comprehension questions. Scientific method. 1. What is the relationship between making observations and forming a hypothesis? 2. Why was it important for Aki to take good notes while conducting his experiment? A. Taking good notes ensures that Aki won't make mistakes when he conducts his experiment. B. Taking good notes allows other scientists to replicate an experiment and verify the results. Zia and Nikole can recreate his armor to use against the hive. C. Taking good notes means no one will need to repeat the experiment. D. Taking good notes means Aki will get a good grade on his experiment. 3. Nikole wants to know which of Aki's armor prototypes will last longest against the hive. Brainstorm 3 ways to collect data on this experiment. 4. What should a scientist do if they find that their data does not support their hypothesis? A. They should change their data to support their hypothesis. B. They should report an accurate conclusion that the data did not support their hypothesis. Then, they can rework their hypothesis and experiment and try again. C. They should redo the experiment and hope that the new data is different and supports their hypothesis. D. They should report an accurate conclusion that the data did not support the hypothesis and do no further research. 5. Aki's data table was destroyed by the hive. Can you categorize the data below as qualitative, QL, or quantitative, QT, data? A. The armor melted at 660 degrees Celsius. B. Before the armor melted, it glowed red hot. C. Aki experimented on the aluminum armor before the copper armor. D. The armor took 5 minutes to melt completely. 6. Nikole's science fair board was also destroyed by the hive. Can you put the steps of her experiment in order from start to finish? Nikole organizes and charts the quantitative data from her experiments. She finds patterns in the data. Nikole spends time reading about the properties of different gases. She researches what other experiments have been performed with lasers. Nikole measures the blast of energy of a laser with helium and krypton gas. She records information about the appearance of the blast, as well as the amount of energy produced. Nikole determines if her hypothesis was supported and creates a presentation and report to share at the science fair. Nikole creates a testable if-then statement based on her research. Nikole notices that using different gases in her laser produces stronger laser beam blasts. She wonders which gas will produce the strongest laser beam burst. Level up. 7. Some scientists argue that reporting conclusions is the most important step of the scientific method. What reasoning would support this claim?